Welcome to Food Safety 5, twice monthly reports from the Food Safety Magazine editorial desk to keep you abreast of top news stories and current events impacting the food safety sector. This episode brings you a spectrum of food science news, including novel cold plasma applications for biofilm and allergen control, accurate sell-by dates informed by microbial data, and an analysis of ultra-processed food purchasing behaviors and nutrition. First, a new study out of the University of Alberta has demonstrated the ability of plasma-activated water and water chemical solutions to effectively inactivate E. coli biofilms, potentially offering a sustainable and safe sanitation solution. Cold plasma technology is emerging as a promising approach for antimicrobial applications. For their study, the researchers assembled a system that converted plasma-activated water into mist. They generated plasma-activated mists of plain water and water with either 100 parts per million sodium hydroxide or 340 parts per million hydrogen peroxide. Two plasma generation times, 10 and 20 minutes, were used. The effective temperature was also assessed by generating plasma using water at 4 degrees Celsius, 21 degrees Celsius, and 35 degrees Celsius. The mists were applied to dual-species E. coli biofilms on stainless steel coupons for 5 and 10 minutes continuously and 10 minutes intermittently. For plasma-activated mists without sanitizers, continuous 10-minute application and generating mist from 4 degrees Celsius water were the most effective conditions, achieving a microbial reduction of 1.56 log colony-forming units per square centimeter. The addition of sanitizers to the mists enhanced the mist's antimicrobial efficacy. The plasma-activated water chemical solutions were generated at room temperature. The greatest reduction of 1.64 log colony-forming units per square centimeter was achieved using the plasma-activated 340 parts per million hydrogen peroxide mist. While traditional methods for biofilm removal include the application of chemical disinfectants that may produce hazardous byproducts and contribute to antimicrobial resistance, plasma-activated mists decrease the need for these chemicals and do not leave residues. Not only is plasma-activated mist more environmentally friendly than chemical treatments, but its adoption could also reduce the expenses associated with costly chemicals and post-wastewater treatment processes. In other cold plasma news, a study from McGill University found that treating peanut protein with cold plasma can significantly reduce its immunoreactivity, suggesting a potential method for lowering allergenic risk while maintaining functional properties. This potential new application for cold plasma is notable because conventional strategies to mitigate the allergenic potential of peanut proteins, like heat treatment, can negatively affect sensory and functional properties, while non-thermal methods, like irradiation, have produced inconsistent results. The researchers applied cold plasma to whole peanut protein extracts, then evaluated allergenic potential using multiple in vitro assays, including immunoreactivity testing, which measures the binding strength between proteins and immune antibodies. Cold plasma treatment reduced overall immunoreactivity of whole peanut protein by nearly 70% after 25 minutes. The researchers also found that treated proteins were more susceptible to intestinal digestion, which may further influence allergenic potential. This reduction in allergenicity was attributed by the researchers to structural changes in the proteins responsible for triggering immune responses. The approach may be applicable to other allergenic foods, including eggs and tree nuts, potentially significantly reducing allergy risks across a wide range of foods. The researchers plan to further investigate underlying mechanisms of cold plasma's effect on allergenicity and optimize the treatment process for efficiency and scalability. Moving to food quality and sustainability, Auburn University researchers are investigating methods to predict meat spoilage based on microbial activity, which would enable producers to affix more accurate best-by or sell-by dates, thereby reducing food waste. According to the United Nations, approximately 10% of all meat is discarded by retailers or consumers due to it reaching its sell-by or best-by date, which are conservative dates that are more an indicator of food quality than safety. Seeking to mitigate the volume of food that is prematurely thrown away by enabling more precisely dated sell-by labels, the researchers observed microbial communities over the shelf life of packaged ground beef, identifying changes associated with meat quality degradation and spoilage. Over 14 days, data on the meat's objective color, lipid oxidation, microbial plate counts, and microbiome were collected, then fed to a machine learning model to predict spoilage. Quality analysis results showed that the meat was microbiologically spoiled after 6 days. The microbiome shifted over the 14 days in a predictable succession pattern, with aerobic bacteria multiplying first, depleting the oxygen present in the package, making room for anaerobic bacteria to grow in the oxygen-depleted environment. The machine learning models were able to accurately predict spoilage based on changes in microbial communities, demonstrating which organisms are important for predicting day of spoilage. Next, the researchers plan to replicate the study with additional samples and sessions, as well as look at other markers of spoilage, with their model hopefully being used in the future to derive more accurate sell-by dates. Finally, a report commissioned by the International Food Information Council, or IFIC, adds nuance to the discussion around the definition and regulation of ultra-processed foods, or UPFs, suggesting that the most common UPF definition, based on the NOVA classification system, does not reliably predict nutrient density, and that policy and recommendations must consider the fact that UPFs dominate U.S. grocery purchases. The report found that UPFs made up approximately 3/4 of total U.S. food and beverage sales, with especially large proportions of shelf-stable and frozen goods, cereals, and prepared meals being classified as ultra-processed. Given these purchasing behaviors, IFIC asserted that dietary recommendations and discussions about significantly reducing or eliminating UPFs must be grounded in the realities of current consumer behavior rather than treating these products as easily avoidable. Additionally, although nutrient density scores were higher among non-UPFs across all categories, nutrient density spanned wide ranges regardless of processing classification, indicating that both higher and lower nutrient density options exist within each group. For example, in the cereal, fresh dairy, prepared meals, and snacks categories, the upper end of the nutrient density range for UPFs exceeded that of non-ultra-processed products, suggesting that some UPFs deliver equal or greater nutrient density than less processed options within the same food category. This finding was especially relevant to the cereals category, where the analysis showed that the most nutrient-dense ultra-processed cereals were not only more nutritious than their non-ultra-processed counterparts, but also 22 to 25% less expensive. Across food categories, the analysis showed that non-UPFs carry a consistent price premium of approximately 16% relative to UPFs. IFIC concluded, these findings underscore the importance of evaluating processing classification, nutrient quality, and price together when considering dietary guidance communication and healthful dietary behaviors aimed at improving overall diet quality. For more information on any of the stories mentioned in this video, be sure to check out the Food Safety Magazine coverage linked in the description. Check back twice monthly on Tuesdays for the latest Food Safety 5 episodes, available at food-safety.com or on our YouTube channel.